Right, we're going to look at solving linear systems using the method called substitution. So let's start out with a system that you could probably actually solve already. Let's look at y equals 10 as one equation and 3x minus 2y equals 4 as the second equation. When we solve linear systems using substitution, what we do is we substitute one variable into another equation. So here we know that y equals 10, and we have a y in the second equation. Since y equals 10, we can substitute that for the y in the second equation. So we can rewrite our equation like 3x minus 2 times y equals 4. And remember what y is. Y equals 10, so I'm going to put that right there. We're substituting the 10 for y. Now we can go ahead and we can solve this because this is an equation in one variable. So 3x minus 20 equals 4. Add 20 to both sides of your equation. So you get 3x equals 24. Divide both sides by 3. And you get x equals 8. Now the solution to a system is actually an ordered pair. So here we have x equals 8. And remember from our original problem we have y equals 10. So our solution is the point 8, 10. So, solving linear systems using substitution means we need to look for the variable that's all by itself. Plug it into the other equation. Alright, that first example was kind of a gimme because you just had y equals a number. We're going to do the same process on this one. It's going to require a little bit more steps though. So the first thing you want to do when you are solving a system using substitution, or why you would even want to use substitution in the first place, is that you have a variable that's all by itself. So look in either equation. You can look in the top equation or the bottom one and look for a variable that is all alone on one side of the equation, or the equal sign. Right here, x is all alone, which means we can substitute x into the second equation. So it says x equals y plus 2. That means wherever you see an x in the second equation, we're going to put y plus 2. So I'm going to go ahead and get this all set up. I'm substituting for x, so I'm going to take him out. I'm going to leave a big gaping hole where he was at. Write everything else as it was. I like to think about it like soccer when you substitute a player. We're going to substitute a new player in for x. He sucks. We got to get a new one. We're going to put in y plus 2 instead. Since x equals y plus 2, we're going to put a y plus 2 wherever there was an x. Now we have an equation in one variable, and we can go ahead and we can solve for that variable. So we're going to distribute. Alright, now we have to combine like terms. So we have, let's see, 4 y's here, and we have negative 7 y's there. 4 y's minus 7 y's is negative 3 y's. Everything else stays the same for now. Alright, now this is an equation, so we can solve it for y. I'm going to subtract 8 from both sides. Negative 3y equals negative 18. Last step is to divide both sides by negative 3. And do not fall for it. Y equals negative 18 divided by negative 3, which is positive 6. Now, that's not your final answer. That's only the y value. We still don't know what x is. So now what we have to do is we have to go back to the original problem and plug our 6 in for y. Now you can use either equation. I'm getting really messy, so I'm going to change colors. You can use either equation you want to plug in for y. To me, the top one seems easier though because there's less numbers, less stuff involved. This means wherever you saw y, you're going to write the number 6. So that's the only place I saw a y, so that's the only place I'm going to write the number 6. So 6 plus 2 equals x, so 8. equals x. All right. And remember, your answer, you write it as an ordered pair. You have 8, 6. Now, if you're wondering, did I really do this right? That was a lot of work that went on. How can I check my answer? You can always check your answers by plugging them back into the equation. I'm going to do that one on this example. And yes, I know I'm running out of space, but we'll be able to do it. I'm just going to do it in the corner here in another color. Y plus 2 equals x. So we said that y was 6. 6 plus 2 equals x, which is 8. True? True. Second equation. 4 times x, which is 4 times 8, minus 7 times y, which is 6, equals negative 10. 4 times 8 is 32, minus 42 equals negative 10. That's how you check your equation. It's always a good idea to do that, because then you know you got the problem right. Alright, again, if you want to solve a system using substitution, you have to have a variable that's all by itself. So if we look at this problem, we look for a variable that's alone, completely alone on one side of the equal sign. And in this case, we actually have it twice. Doesn't matter which one we can choose. I'm going to choose the y in the top equation. Y in the top equation equals x plus 9. So this is what I'm going to substitute for the y in the second equation. So wherever I saw y in the second equation, I'm going to write x plus 9. The rest of it stays exactly the same. Now if you look at this, we have an equation with variables on both sides. We can solve this. We know how to do this. First thing we need to do is get those x's on the left. So I need to add 2x to both sides. That way they go away on the right. 1x plus 2x is 3x. 9 stays the same, and those cancel. Alright, one last step, move that 9. 6 minus 9 is negative 3. Divide both sides by 3. Get our final answer of x equals negative 1. Are you finished? No, the correct answer is no. What do we need to do next? We need to find y. And to find y, we are going to use that x that we worked so hard for and plug it into one of the top equations. Doesn't matter which one you want to use. I'm going to choose this first one and y because it has less numbers in it and no negative signs. I know that's silly, but I'm less likely to make a mistake when there's less complications. So, y equals x plus 9, but I already know what x is. X equals negative 1. So y equals negative 1 plus 9, y equals 8. So our final answer is negative 1, 8, because x goes in the first position in an ordered pair and y goes in the second position. Again, you can check your answer by plugging it into both equations. You can pause the video and do so now. I'm trusting that everybody checked their answer on the last one instead of just assuming we got it right, but alright, here's another example. I always said if you want to use substitution, you look for the variable all by itself. Do you see a variable all by itself in this problem? There isn't one. However, there is a way we could make a variable be all by itself. Either equation would work. If I wanted to make y be all by itself in the top equation, what is there that's with the y? The x. So if I wanted to move that x, subtract x from both sides, I could write myself a new system. The new equation would be y equals negative 3 minus x, or negative x minus 3. It doesn't matter which order you do it in. Now, if we were ignoring that guy, we can look at these bottom two equations and we can solve that system. Because the question we need to ask ourselves is there a variable by itself? Yes, there is. Y is by itself. Y equals negative 3 minus x. There's a spot for y in that equation, so we can go ahead and we can substitute for y. So 4x plus, and I usually use big gaping hole for the guy I'm taking out of the game, equals 0. And in for y, we're substituting negative 3 minus x. It's my sports announcer voice. Okay, so it's 4x plus, and I have parentheses. Do I need those parentheses? Is there anything in front of it? Just a plus sign. And if you distribute a plus sign, nothing changes. So 4x plus negative 3, which is minus 3, minus x equals 0. Combine like terms would probably be our next step, because I see I've got 4x's here and I've got a negative x there. I can put them together because they're on the same side of the equal sign. There's the equal sign. They're on the same side. I can put them together. 4x minus x is 3x. Now there's just one last step we need to do. Add 3 to both sides. So we end up with 3x equals 3. Divide both sides by 3. You get x equals 1. We're not done yet. We need to find y. Good thing we have all sorts of ways to find y. I'm going to lose that one. Why? Because it looks to me like the simplest one. Y equals negative 3 minus x. All I need to do is plug that number in for x. So, y equals negative 3 minus x. But I know that x is 1, so it's minus 1. Y equals negative 3 minus 1, so y equals negative 4. So we can write our final answer as the point 1, negative 4. And we can check our answer by plugging it back into the original system of equations. I know we've been doing a lot of examples, and I appreciate you bearing with me, but I wanted to get a couple more in where we have to think a little before we can get our final answer. So 3x plus y equals 4, and negative 3x equals y minus 7. Do you see a variable all by itself? I hope the answer was no, because there isn't one all by itself. There's a couple ways we could get one all by itself, though. We could change the first equation. If we wanted to get y by itself, we could just go ahead and minus 3x from both sides. In the second equation, if we wanted to get y by itself, we could just add 7 to both sides. That's what I'm going to do, because to me that seems a little bit easier. Alright, so now we have the equation negative 3x plus 7 equals y. And I'm going to rewrite that top one again. He's gone. So I can see them right next to each other. 3x plus y equals 4. So now we can go ahead and we can substitute. We have a variable all by itself. It's y. We are going to substitute negative 3x plus 7 into our equation for y. So 3x plus big gaping hole where y was equals 4. Inside that big gaping hole, we're going to put negative 3x plus 7, substituting into the game. Alright, now I put them in those parentheses. Do I need to keep those parentheses there? Is there any distributing that needs to happen? Not in this case. So 3x plus negative 3x plus 7 equals 4. Combine like terms step now. 3x minus 3x. Okay, if I have 3 bananas, I eat 3 bananas. What do I have left? Nothing. 0. They're cancel out. So my equation says 7 equals 4. Now we can't solve anything. We don't have any variables that are left. This is a special case, so we need to remember that. It is special case. When you end up with two numbers that are not equal to each other, say to yourself, self, when does 7 equal 4? And then you answer yourself and you say, self, that never happens. So in this special case, there is no solution. There's no solution to this equation. There's no values that would make it true. So another way you can write no solution is you can write a 0 with a slash through it. You won't see this special case very often, but every once in a while you will, so it's important to keep in mind. I didn't want to leave on a special case note, so we're going to try one more. Solving systems with substitution means what? Looking for a variable all by itself. If you don't have a variable all by itself, you make one. In this case, I'm going to look for a variable alone. Do you see him? He's there. It's y. Y is all alone. Hooray, that means we don't have to do anything. We are substituting 4x because 4x equals to y. So wherever we see a y in the second equation, we're going to put a 4x. So 2x minus big gaping hole where y was equals negative 1. And wherever there was a y, we're going to substitute a 4x. Alright, now in this case, those parentheses are necessary. Got to bring that negative into everything inside the parentheses. So 2x minus 4x equals negative 1. Now that's all together on one side of the equation, the 2x and the negative 4x. So we can combine those two. 2x's minus 4x's is negative 2x's equals negative 1. Divide both sides by negative 2. And we get our final solution, which is x equals, negative over a negative is a positive, 1/2. Which is okay. We can have fractions for answers. Now, we are not quite completely done. When you write an ordered pair, you have two parts to it. We only have the first part, the x. We need to find the second part, the y. And to do that, we need to go back to our original sets of equations. Now, we can substitute that x into either equation. I think you guys know which one I'm going to pick right now. The top one, y, because it's simpler. So y equals 4 times x, but we already know that x is 1/2, so we can replace the x with a 1/2. What's half of 4? 2. So y equals 2. I'm going to put that into my final answer, and if I were being really, really good, I would go ahead and plug those numbers into my original two equations to see if they worked. Now, just a quick recap so that we can remember what we did throughout this whole video. If I were you, I would take a screenshot of this when I was done. I would carry it around with me or save it somewhere where I could see it again. So this is the steps for solving with substitution. I'm just going to write sub at the top. Set one equation equal to one of the variables. So that means look for the variable all by itself, one of the variables. Then what you do is you substitute that expression into the other equation and solve it to get the value of the first variable. So this is where we actually substitute in that step, and we solve. After you end up getting the value of that variable, whether it's x or y, you plug that answer into one of the original equations or one of the new ones and solve for the other variable. And when you're done, you write your solution as an ordered pair. Remember, that means in parentheses, x comma y. And you are sure always, always, always to check it by plugging it back into both equations. So that was solving linear systems using substitution.